Solve the equation. We can begin by finding our equal sign and looking to see if there's any simplifications that can occur on the left side or on the right side. We'll bring that equal straight down to keep things lined up. And then we'll look over here on the left and notice that we have a couple of z terms. The rule for combining like terms is to keep the variable part, so we'll write down the z, and then we need to combine their coefficients. Notice that if you have z all by itself, that the coefficient is known to be 1. I just chose to write the 1 in. That's optional as long as you keep track of it. But it might make it easier to see the next step, which is to subtract the coefficient 1 minus 9, which gives us negative 8. So we end up with negative 8z on the left. Now we want to see if anything can combine on the right. And we have two z terms that can be simplified. Again, we'll write down the z, and then we need to combine the coefficients. Notice that minus z can be thought of as minus 1z. This time I won't write it, I'll just do the subtraction. 5 minus 1 is 4, so we get 4z. The only other term on the right is the minus 7, so we make sure to bring that down. Now that we've finished all the simplifications possible on the left, and there also are no simplifications remaining to do on the right, we want to proceed in such a way that we get variables on one side and constants on the other. Notice that right now we have z's on both sides, but we have a constant only on the right side. So in this case, I think I'll decide to keep my constant on the right and work towards getting my variables to the left, which means I need to get rid of this 4z term. To get rid of a 4z term, I'll have to subtract 4z. I'm subtracting it here on the right, so I have to do the exact same thing on the left. Now, I'll draw a bar to show that I'm going to add or subtract, and on the left, I get negative 12z. Remember, you keep the z and combine the negative 8 and the negative 4. On the right side, I need to combine those z terms, but since we are subtracting 4z from 4z, that gives us a 0, so we just say that they cancel. So I bring down the negative 7 and I'm ready to proceed. Now that I have my z's only on the left and a constant only on the right, I want to get z all by itself. This next step will involve me writing on top of this step, so for the sake of your notes, I'm going to recopy this step first. And then I'm looking at z and noticing that they're multiplying z by negative 12, and I want z by itself. So I have to do the opposite. The opposite of multiplying z by negative 12 is to divide by negative 12. So I do that to both sides. This allows those two negative 12s that are on the left to cancel, which leaves me just z equals, and then on the right side I need to reduce this fraction. The negative on top and on the bottom, you'll recall, the rule of sign numbers tells us these two negatives give us a positive. I don't need to write the positive, I just need to reduce 7/12. Since nothing goes into the top and bottom evenly, that just stays as 7/12. Notice that the directions say to leave our answer as an integer or simplified fraction. The word or here doesn't mean we get to choose. 7/12 is not an integer. What it's saying is we need to leave it as a fraction. Notice that in the past we sometimes take the 7 and divide it by 12 and turn it into a decimal. And in many contexts that would be a fine way to leave your answer. But in this context they're not asking for a decimal. They want us to leave it as a simplified fraction. So 7/12 is our final answer. Solve the equation. To begin, we need to look at each side and see if there's any simplifications that can be done. On the left-hand side, we have this distributive property, so we can take the 6 and multiply it by each of the two terms inside parentheses. 6 times 2 is 12, so 6 times 2x is 12x. The 6 times the 1, since they're both positive, the result will be positive, and 6 times 1 is 6. And that equals the right-hand side. The left-hand side is now completely simplified. So we need to look to see what we can do on the right. Since 3x and negative 8x are common terms, we'll keep the x and we'll combine the coefficients. 3 minus 8 is negative 5, so we get negative 5x. Our next goal is to get any x terms on one side and any constant terms on the opposite side. Since positive 6 is our only constant term and it's already on the left, we might as well leave it on the left and work on getting the 12x and the negative 5x both on the right. So we'll need to get rid of the 12x. To get rid of an entire term, you add the opposite. The opposite of 12x is negative 12x. Or you can think of it as 12x minus 12x. Because this is an equation, whatever we do on the left, we have to do on the right. So notice I've written minus 12x below the negative 5x term. I draw the line to indicate we're going to add all these terms up. The 12x's cancel, which just leaves us with the 6 on the left side. And on the right side, we have a negative 5x and a negative 12x, which gives us negative 17x. Next, I'm going to recopy that equation. For the purposes of your notes, I'm going to have to write on top of it, so I like to keep it in its original form. And then we need to think about getting x all by itself. Since x is being multiplied by negative 17, to get it by itself, we have to do the opposite, which is to divide by negative 17. Notice again, if I divide one side by negative 17, I have to do that to both sides. The negative 17s will cancel, leaving us with just x on the right, and that will equal our fraction on the left. 6 over 17 doesn't simplify, but it's not standard to leave the negative in the denominator. So we can either leave it up top, or we can write it out in front. Notice that the directions say to leave this as a simplified fraction. So don't take 6 divided by 17 on your calculator and leave it as a decimal. There are times that we do that, but in this case it's asking specifically for the simplified fraction. One more thing. This equation is written kind of backwards, so this is not necessary, but some people like to rewrite this as x equals negative 6 over 17. Either way, negative 6/17 is our final answer. Solve the equation. To begin, we need to simplify the left, and we'll need to simplify the right. Let's start on the left. The 7y we can bring down, and the 3 will need to be distributed to both terms within the parentheses. 3 times y is 3y, and 3 times negative 8 is negative 24. On the right side, we have a distributive property. The 4 times the y is 4y, and the 4 times the positive 2 is positive 8. Notice that the parentheses end, so do not distribute the 4 to that negative 3. Just bring it down. Now we continue to simplify. Notice on the left, there are some y terms that are common. So we can combine them by adding their coefficients. 7 plus 3 is 10, so we get 10y. The minus 24, we can just bring down. On the right-hand side, the 4y is not common with any of the other terms, so we can bring it down. The positive 8 and the negative 3 can be combined. 8 minus 3 is positive 5. So notice now that the left side is completely simplified. and the right side is completely simplified. So now we'll need to get all of our y terms to one side and all of our constant terms to the other side. We can start with the y terms. You actually have a choice whether you want to get rid of the 10y or get rid of the 4y. The way some people decide is they always like to get rid of the one on the right because they prefer at the end of the problem to have their variable on the left. The other strategy is to get rid of the smaller one because then when you do a subtraction later on, you end up with less negatives dragging through the problem. But you can have the confidence to know that no matter what decision you make, you end up getting the same answer. The two strategies I mentioned actually both would lead us to getting rid of the 4y. To get rid of the 4y, you subtract 4y, and whatever you do to the right side, you have to do the same thing to the left side. Notice I write minus 4y under the term that it's common with. We then draw a line and we'll combine all the terms. 10y minus 4y is 6y. We bring down the negative 24. And on the right side, 4y minus 4y is 0. But we usually just say that they cancel. And then we can bring down the positive 5. Because it's positive, we don't have to write the plus. Now we want to get rid of the constant that's on the left. Notice that 6y is all by itself on the left side, so we want to take our constants to the right. So that means we have to get rid of the negative 24. To do that, we add 24, and we need to do that to both sides. We draw a line to indicate we're going to add. We bring down our equal sign, and then we go column by column. The 6y can just come down. The 24's cancel each other out. And on the right side, 5 plus 24 is 29. Let's recopy that up here so we have a little more room. And now we want to get y all by itself. Notice that y is being multiplied by 6. The opposite of multiplying by 6 is dividing by 6. So we divide both sides by 6. The 6's then cancel each other out, leaving us just y on the left. 29 over 6, there's nothing common to the top and the bottom, so that's already reduced. You can take that to a mixed number, which would give us 4 and 5/6. Either answer is acceptable, so this is our final answer.